All right, let's dive in. Today, we're taking apart a true legend in the electronics world, the Arduino UNO R3. We're going to find out exactly what makes this little green board tick.
So, this is it, the Arduino UNO R3. Chances are, you've seen this thing before. For more than a decade, it has been the absolute go-to starting point for makers, students, and hobbyists, building everything from simple blinking lights to, full-blown complex robots. It's small, it's affordable, and it is just packed with potential.
And hey, don't just take my word for it. That quote, that comes straight from the folks who made it. They designed the UNO from the ground up to be a super gentle introduction to the worlds of hardware and programming, which, let's be honest, can be kind of intimidating. This thing is built to be your first and best step.
Okay, so before we get our hands dirty, let's take a quick tour of the board's most important landmarks. Think of this as our virtual unboxing. We're just getting familiar with the landscape before we start building.
And this diagram right here is going to be our map for the tour. It's called the board topology. Now, I know it might look a little technical, but trust me, it's really just a simple layout of all the key spots we're about to explore.
So the most obvious place to start is right here, with this big silver box. This is the USB-B port. It's basically the main gateway to the board, and it does two really important jobs. First, you use it to upload your code from a computer, and second, it can actually power the whole board right from that same connection. But what if your project needs a little more juice than a computer's USB port can handle? Well, that's where this round power jack comes into play. It lets you hook up an external power source, like a battery pack or a wall adapter, for those more demanding projects. Things with motors or tons of lights.
All right, so we know how to power it up and how to talk to it. Now, let's get to the really fun part, the part that does all the thinking. Let's talk about the brains of the operation.
At the very heart of the Arduino is this thing called a microcontroller. And to put it simply, it's a whole computer packed into one tiny chip. Its one and only job is to run the program you give it over and over and over again. This is literally the brain that makes every single project smart.
Now, a brain needs memory, right? Well, this one, the ATmega328P chip, actually has three different types. First up is 32 kilobytes of flash memory. Think of that like a hard drive. It's where your code, or as Arduino calls it, your sketch, gets stored permanently. Then there are 2 kilobytes of SRAM, which is like the RAM in your computer. It's the active workspace where your code is actually running. And finally, you've got 1 kilobyte of EEPROM, which is for long-term storage for data you want to save, even when you unplug the board.
Okay, so the brain has all these instructions, but how does it actually interact with the outside world? Well, it does it through these rows of little holes, which we call pins. You can think of these as the board's senses and its limbs. They're how the Arduino connects to sensors to feel the world around it, and to things like lights and motors to act on it.
And this is a really crucial point. Not all pins are created equal. You've got two main types. Digital pins are like a light switch. They're either all the way on or all the way off. Super simple. They're perfect for things like turning on an LED or checking if a button has been pressed. Analog pins, though, they're more like a dimmer switch. They can read a whole range of values, which is absolutely essential for sensors that measure things like temperature, light, or sound.
Okay, we've toured the hardware. We understand the brain and the senses. Now let's talk about the two essential ingredients that you need to actually bring a project to life: a steady supply of power and a set of instructions, which we call code.
This power tree diagram here, it basically just shows how the board intelligently manages its energy. You can see the two ways in we talked about, the USB port and the external power jack, which is labeled VIN. The board has its own built-in voltage regulators to make sure everything gets the right amount of power and runs safely. Pretty smart.
So, you might be thinking this all sounds pretty technical, but here's the best part. Getting started is unbelievably simple. It's really just 3 steps. First, you connect the board to your computer with that USB cable. Second, you write your code, or let's be real, you'll probably copy and paste your first bit of code using their software. And third, you click upload, and your program, your sketch, gets sent to the board, and you can see it work instantly. That's it.
So, with this awesome mix of power and simplicity, who is actually using the Arduino UNO R3? You might be surprised, because the answer is, well, it's pretty much everyone.
Its main audience, for sure, is makers and hobbyists. It's just such an accessible way to get into electronics. But it's also become a standard in education, used in classrooms and science projects all over the world. And
Get this, it's so reliable that it's even used as the brain for some industrial machinery, sometimes inside what's called a programmable logic controller, or PLC.
So there you have it, the Arduino UNO R3. It's so much more than just a circuit board. It's a launch pad. It's this powerful, versatile, and seriously beginner-friendly tool that's designed to turn your ideas into reality. So now that you know the board, there's really only one question left. What will you create?